Okay guys, let's do some algebra. We're going to start with number 6. On number 6 I noticed something that has not happened on this worksheet yet. I have two x's, x terms, but they're both on the same side of the equal sign. So be careful not to try to move one of those to one side or the other. I had students adding 9 to both of those, but they're on the same side of the equal sign. So you're not doing the opposite. You're not doing the inverse, you're actually just combining like terms. So what is 4 minus 9x? You're just going to combine these together, and you'll get negative 5x plus 3 equals negative 32. Now you can just go along your merry way and keep solving for this problem. We're going to subtract 3 from both sides. Negative 5x equals negative 35. And then look at that. When we divide by negative 5, because we're dividing a negative by a negative, they're going to cancel, and x equals a beautiful 7. Now let's look at number 9. I wanted to throw one in there that involved distributing. The first thing that you would do before anything else on number 9 is distribute that negative 9. It's not a 9, it's a negative 9. So be careful. Cursor's in the way. Okay, so we get negative 18x plus 27, because the negative 9 times the negative 3 is a positive 27, equals negative 7x plus 2. Now, we want to get all of our x's on one side and all of our integers on the other side. I personally love when x is positive. So I'm not going to move the 7. I'm going to move the 18x. I'm not going to move the 7x. I'm going to move the 18x because I want to make sure that x is positive. So I'm going to move the one that's the smallest. So I have 27 equals 11x plus 2. And now it's looking nice and easy. Subtract 2 from both sides. Looking good. Now I know I divide by 11. Here's where it gets tricky. How do I write my answer? How does my teacher want me to write my answer? When you do 25 divided by 11 in your calculator, you don't get a very pretty number. And when you don't get a very pretty number, especially when the number goes on forever, you do not write it as a decimal. We actually don't want you to write it as a mixed fraction either. We want you to leave it alone. That cannot be reduced at all, and so we want you to leave it as 25/11ths. That is your final answer. Don't do anything to it. Don't convert to a mixed fraction, and don't try to write it as a decimal. Okay, now we're going to tackle a factoring problem. Hopefully you remember from class that you cannot factor a quadratic until it equals 0. That is our very first step, is we always want it to equal 0. Doesn't equal 0, don't try to factor it. So we need to move that 36 over. The opposite of minus 36, is plus 36. So we have y squared plus 13y plus 36 equals 0. Don't be scared just because it's a y and not an x. You're not going to treat it any differently. Now this one doesn't have anything in front of the y. That's great news. I know I can just stick a y and a y. Now is when we brainstorm. You could write down your brainstorm, or you don't have to write down your brainstorm. It's up to you. Numbers that multiply to get 36. 3 and 12. 9 and 4. 36 and 1. You keep listing out factors until you find 2 that could make a 13. Whether you're adding or subtracting doesn't matter. Could I make a 13 out of a 3 and a 12? No. You lost. Could I make a 13 out of a 9 and a 4? Absolutely. So I don't worry about the signs yet. I just stick the 9 and the 4 into those parentheses. Now, we got lucky on this problem. Everything's plus. Plus 13, plus 36. So we don't need to worry about the positive or the negative. We know that it's plus for both of these. The biggest mistake that students make is they put 4 and 9, final answer, that's what y equals. But that's not what y equals. That's not what it equals. We want to know, what does y equal if y plus 9 equals 0? Oh, y equals negative 9. What does y equal if y plus 4 equals 0? Subtract 4 from both sides, y equals -4. So that's your final answer on number 14. Let's try number 16. This one's going to have some negatives in there. We're, of course, going to set it equal to 0. X squared minus 7x minus 18 equals 0. We're going to open up our parentheses and get ready for factoring. Get in your factoring position. We are going to put an x and an x here because that's the only two things that multiply to get x squared. X times x. Or, of course, x squared times 1, but we know we're supposed to separate those. Then we're going to brainstorm things that multiply to get 18. 3 and 6, 9 and 2, 1 and 18. We know that our goal is to make a -7. Our goal is to make a 7. And so which combos could you use and make a 7? Can I make a 7 out of a 3 and a 6? Could I make a 7 out of a 9 and a 2? Ding, ding, ding. You don't care about the sign yet. Just throw the 9 and the 2 in there. Now is where we're going to think about the signs. I need it to be a -7. So would I do 9 minus 2, or would I do 2 minus 9? And for the 7 to be negative, we want it to be 2 minus 9. 2 minus 9 is -7, which is our middle term. That's what we wanted. Those are not the answers. Do not stop there. No, those are not the answers. The answers are -2 and 9, because you're asking yourself what x value would force the things in the parentheses to equal 0. All right, ready? Toughest one on the page, number 18. We know what to do first, guys. 2x squared plus 5x minus 42 equals 0. We know what to do next. We open our parentheses. There's only one combo that will make 2x squared. It's 2x times x, other than 2x squared and 1. Okay, so now's when we always do our brainstorming. So we need numbers that can multiply to get 42. So we've got 2 and 21. There's a weird one. We've got 6 and 7. There might be some other ones, but I'm going to stop there and see what we have. Okay? I'll throw one more up there. 3 and 14. Okay. Now, the kicker here is that this problem has what's called a leading coefficient. It has a number in front of the x squared other than 1. That throws things off. So, we're going to use our pairs underneath the 42, and our goal is to make a 5. Well, I'll circle this one. Our goal is to make a 5. But the trick is, the kicker is you get to double one of them. So you get to double one of those numbers, and together with his or her pair, you need to be able to make a 5. So let's try it. If I double 2, I get 4. Can I make a 5 with a 4 and a 21? No. If I double 21, I get 42. Can I make a 5 out of a 42 and a 2? Oh my goodness, that's not going to work. Okay, let's try the next one. If I double 6, I get 12. Could I make a 5 out of a 12 and a 7? Absolutely. Ding, ding, ding. So this one's the winner. This pair is the winner. And 6 is the one that needs to be doubled. Now we know that when we FOIL, the term that gets multiplied by the 2 is the one farthest away from it. So I'm going to throw my pair in there, and I'm going to put 6 in a strategic spot where it'll get multiplied by the 2. Now we just need to decide what signs to use. It's a -5, even though I wrote all over it and it looks ugly now. No, it isn't. It's a +5. Sorry. It's a +5. So we've got a 12 and we've got a 7. How do we make a +5? 12 minus 7 or 7 minus 12? And we know it's going to be 12 minus 7. That 6 is going to turn into our 12, and then we want it to be minus 7. We've done a lot of work so far. You might be very confused, and that's okay. You can watch it again. But we're not done. So make sure that before you write your final answer, you set these equal to 0, whether you just do it in your head or whether you write it down. So the first answer is really easy. X equals -6. That one I can do without writing it down. The second one takes 2 steps. You have to solve for x. So I'm going to add 7 to both sides. 2x equals 7. And then I'm going to divide by 2. So x equals 6 and x equals 7 halves. Yes, it is a fraction. If you put 3.5, you wouldn't get it wrong, but we like improper fractions better. So that's the final answer on number 18, -6 and 7 halves.